So first question, solve this equation. So we start off and we look and see, we're looking for 3 to the power of x basically anywhere along this equation. So before we start into it, to replace it, we're going to rewrite. Addition means you added to get to it to look like this. And again, I back out. So again, I'm just kind of deconstructing it back into the most simple form, which is 3 to the power of x. Now, 3 to the power of x is y. So that's going to be y squared. 3 squared is 9. Minus 28. Again, I'm going to replace 3 to the power of x with y plus 3. So what I end up with is a quadratic in y. Now, at this stage, you can do your null factor theorem or your minus b formula. So let's say we try our just the null factor theorem. The plus means the signs are the same. They're both minus. And we need 28. So I'm assuming we need this kind of a setup. So we just do the smiley face check. Minus 1y minus 27y is indeed minus 28. So we're all good there. So we allow the 9y minus 1 to equal 0. Y minus 3 equals 0. 9y equals to 1. And y is equal to 1/9. And y is equal to 3. Now, of course, we're solving for 3 to the x. So we now allow both solutions to equal the answers that we got. Sorry, that's the dog playing with a toy in the background. So that becomes 9 to the power of minus 1. This becomes, well, this is basically done for us because that's automatically 1. Over here, we would change 9 into 3 squared. And that becomes this. So now this is kind of a junior cycle stuff. Also, of course, because you know how to use logs, you can use logs from there. But sometimes I just go back to the junior cycle. These are index equations. You just want both sides to match. When the base numbers match, you just compare the indices. So you can do it either way. It's no problem. So that was worth 10 marks. And the two answers were minus 1 and, were 1 and minus 2.